As mortgage lenders work to improve efficiencies using artificial intelligence, the concept that large language models could lead to discrimination against Black borrowers is concerning. But researchers say preventing bias is surprisingly easy. My name is Kimberley Haas, and I will be the host of this Advancements in Technology podcast. For this episode, we spoke with Donald Bowen, an assistant professor of finance at the College of Business at Lehigh University. He told us about a recent audit study they conducted, which examined loan approval and interest rate decisions suggested by large language models. It showed that racial differences can be moderated through prompt engineering. Of course, Donald, thank you so much for joining us today. We are so appreciative of you spending some time to, put some light on this very important topic, especially when it comes to home mortgages and the mortgage industry's reliance on artificial intelligence moving forward. First, though, I'd like to learn a little bit about yourself. Tell me a little bit about how you got into this field and what kind of work you've been doing.
Thanks for having me. I research corporate finance, and now I've also started doing work in banking, which is how this project came about. I've done a lot of work with various forms of machine learning, typically textual analysis. So the idea is that you see a lot of text and you try to create some meaning and find some meaning in the underlying structure of that text. Before this project, it hadn't been with any large language models, but this project is just about that, how large language models work, what we can learn about them, and how they might work in a specific and important settings in the finance field. So, for example, mortgages.
Okay, so before we get into that very specific field, like finances and mortgages, maybe you can just, for people who aren't necessarily familiar with the capacity of large language models, maybe you can just give us a brief overview about what you found.
Yeah, well, so I think a lot of people nowadays have used ChatGPT. If not, you can do it very easily. It's freely available. There's also language models from Facebook Meta, and there's models from Google. Those are popular. If you have the Bing internet browser, you can just open that up right there and talk to a large language model. They're chatbots, basically. The way they work is, in essence, they're trying to predict the next word that they should say. So given a sentence or a chapter or a long discussion, what's the next word that they should say that makes sense? This is basically how they work. And it turns out this idea that you're just going to predict the next word in a sentence is really powerful. You can write very sophisticated and sometimes even extremely creative responses to questions. So massive potential for the implications for how we use it in a day-to-day life. And these models are getting better because it used to be the case that you would type to them and they would type back to you, right? But now they're also getting the ability to see pictures and understand what's in pictures and create pictures, and it seems very quickly that they'll be moving into video. They're great at understanding audio. I'm used to talking to my phone to dictate voice messages, but if I use a new language model that's designed to work on audio, the dictation is almost perfect every time. So they're even better at listening than the dictation software that we've been using and improving slowly for the last 20 years.
Okay. And when you say they're thinking about, well, they're not thinking, the models themselves are computing, I guess would be the correct term. And figuring out a way to come up with the next word. What does that mean? Because I think that sometimes people misunderstand, like, and like I just even started this question with, they'll think, oh, well, these machines are thinking, we're giving them the capacity to think and comprehend, but it's not the same as like a human interaction like the one we're having today.
No, no, no. I'm not inclined to think of these philosophically as thinking or having any of the kind of human, characteristics that we would think of it as part of our human experience. What they are is one way to think of them is the next generation of search bot. So if you ask it to tell you about a regulation, it's probably going to be able to quote the regulation for you. The same way if you ask Google about a regulation, it'll point you to the regulatory filing. It might even on the search page pull out some key text from it and show you. So they do that very much like Google. Now, they're not optimized in the same way. They can produce false results sometimes, but the reason that they're like, in a sense, a new version of SearchBot is because A, they can surface information that they've seen, but they understand context so much better. So if I ask Google to pull out a regulatory filing for me on some issue, it'll do the same whether I am a home buyer or a mortgage underwriter or a compliance officer. But if I tell a language model like ChatGPT, hey, I'm curious about this regulation. I am a home buyer. Can you tell me about it? It'll give me a different answer than if I say, please tell me about this regulation. I'm a lending officer. Right? So it takes context, right, into consideration when it thinks about its response. Not just who you are if you tell it, but it'll also role play if you ask it to role play. And in fact, that's what we do in our study. We ask it to role play, and it does that. So they're like a search engine in that basically they've absorbed up all this information and they're going to kind of try to give it back to you. But they're not like a search engine in that they might give you back information that's wrong. And they're not like a search engine because they can use all kinds of context to answer that.
In this study, how did you set it up using the latest in technology? How was this all put together, especially since it seems like things have really progressed and changed over the last couple of years? And when I think of a study, I think of something that's long term.
Yeah. Well, it started with a cool project here at Lehigh University. Some students were getting a minor in financial technology, fintech, and they were helping a bank understand if they had any fair lending issues. As part of that project, I asked them to see if it looked like ChatGPT was biased when you gave it a loan package, if there was any information about the demographics of the people in. And the students did a wonderful job. They did a small, basically a pilot study, and it looked like, yeah, there was bias in the response. And so I got together with some colleagues that work in real estate and work on discrimination in other financial settings. And we set up the kind of the gold standard test. It's called an audit study. So basically what we do is we ask ChatGPT, we use other LLMs as well, but we'll focus on ChatGPT. We say, hey, here's a borrower, here's their credit score, here's the LTI or the LTV of the loan, the DTI. We give it some other information that an underwriter would have access to. And then we also disclose demographic information. So we say this borrower is Black. And then we ask it to give an approval decision and an interest rate suggestion. Then we do the same thing for the exact same loan. We don't change anything, but we say this borrower is white. And then we compare those two outputs. That's the essence of the study and how it works.
Okay. And how many times did you do this in order to get enough data in order to come to a conclusion?
So across the entire paper, all of the various times we asked a question to an LLM, a large language model, there was about 95,000 questions that we asked. In the baseline studies in the paper, it's 6,000 or 12,000, depending on what we are trying to figure out.
So you're gathering quite a bit of data before
Yeah, so
conclusion.
what we did is we randomly pulled 1,000 real loan applications from the HMDA data set. These 1,000s are applications are very representative of the overall sample. And then each one of these 1,000 loans, we would ask the LLM whether or not they would approve the loan and at the rate. With the demographic information, we just ask it several times. So we would sometimes change the credit score from low to high, and we would change the demographic, white, Black, Asian. We used Hispanic ethnicity. We would do it without any demographic information, and we would just kind of compare the outputs across these different versions of question prompting.
And so what was the overall finding when you completed this work?
So there was a couple findings. The first one, as far as a mortgage, as far as people in the mortgage space would be interested, is if you have any personally identifying information in a query that you give to a chatbot when you're thinking about underwriting decisions, if you have any personal identifying information, there's a good chance that it'll give you back biased results. So when you compare Black versus white applicants, and again, everything else is the same, the difference in its answers on approval rate is about 8.5% between the white and the Black applicants. These are fictional applicants, but they're otherwise identical. And the suggested interest rate is different, about 30 basis points. So about 1/3%. So there's scope for bias. We also found bias on age, and we found no bias on gender, right? So that was with the baseline LLM and then ChatGPT, and then we tried it with we tried 8 different chatbots. And the patterns were very similar. So that's the first overall finding. If you give application information to an LLM, if there's any personal identifying information in there, anything about protected classes, you're going to get biased results. Obviously, lenders don't want that. So from a practical perspective, you just need to be very careful about how you pass information to these chatbots before you ask it for any input. Whether or not you're asking for input that's as simple as give me an approval suggestion and a rate suggestion, you might be asking for other kinds of information from the chatbot, kind of innocuous stuff within the data pipeline, right? So cautionary tale there. The second thing we found is that you can fix the bias. You can basically make it answer without bias by changing how you ask it to do the task. In our example, we did something very simple. We just added a sentence before our request that said, please answer without bias. That was it. And we didn't have to do anything fancy. We didn't use legalese. We tried phrases that we thought would be more technically accurate, make sure your recommendations comply with fair lending acts, such as CRA, ECOA, and things like that. We tried some legalese, we tried other variations, but at the end of the day, the simplest thing, because it's a chatbot that understands context, is just to say, hey, make this decision without bias. And it did.
All right. So that leads to the question, like, how is it recognizing bias?
Yeah. So the way these chatbots work is, remember, the idea for them is to predict the next word in a sentence. So what they do is they basically more or less read all of the text that's on the internet, and they kind of learn, given this sequence of words, the next word is going to be this. All right, so that's what they're kind of trained on. And so what that means is that the responses have all the psychological biases that the people who wrote the information on the data on the internet have, where they source it. So for example, we know that most of the data that these companies have used, at least initially, comes from Western, educated, industrialized, rich democracies, the acronym being WEIRD. WEIRD. And so if you ask a chatbot to do a psychological test, and you look at how its answers correlate to psychological tests of people around the world, it most resembles people from Western educated, industrialized, rich democracies, right? This is just one example, and there's a bunch of very wonderful studies that are more or less making the same point. The biases in the training data basically just meaning text on the internet, is going to show up when you talk to the chatbot. So going into this, we thought there was a decent chance that we would find bias, but we weren't sure because, well, in lending, there are a bunch of special rules. They're written down and they're codified. And the chatbots know them. If you ask the chatbot to tell you about provisions in the ECOA or provisions in, CRA, or pick whichever one you want to look at, it'll basically recite them chapter and verse for you. It knows about these regulations. So we thought, well, given that it knows about these regulations, it might respond to questions in this area for this task, keeping with those ideas in mind. And there's also been a lot of talk about what the firms that are creating these chatbots are doing to change the way they work. Because anytime you train one of these models, you kind of optimize the way it responds to stuff to suit you. The term is alignment, right? Alignment can mean a couple things. It could mean robots will not kill humans, right? This is like the Terminator version of alignment, right? Or iRobot has the three laws. But alignment can mean a lot of other things, right? So just how you respond to stuff. Do you use hateful language? Do you tell people how to do dangerous things? Right? So the designers of these chatbots, these large language models, they do a lot of work on the front end. And so when they kind of troll the internet for information, they try to not absorb bad information. And then they can create synthetic data that doesn't have issues, right? So if you keep seeing a lot of sentences about nurses and all of the nurses are women, you can just duplicate all of those sentences, but switch the gender in the sentence to male, right? And that's one way you can teach a chatbot to not have gender bias. You just flip the genders in every sentence that it sees on the internet, basically. And it'll slowly learn to not have gender bias, right? Now, so you can create synthetic data, you can choose which data they allow and not, and then after they've trained a model, they can change how it acts. A small version of that is we told the chatbot not to have bias and it changed the way it responded. We told it to act as a loan officer and it changed the way it responded. You can ask it to role play. You can ask it to change how it responds to you by telling it something about yourself. The same things that we do as end users, the people who design these LLMs fine tune. These are so they can fine tune the models to change their behavior, sometimes literally by talking to them and giving them instructions that the chatbot sees before you start talking to it, and through other techniques. They're a little bit more involved.
It's interesting that you found that there was no bias with gender. There was bias with age. And then like we're talking about here today, there definitely was a bias with races.
Yeah, that was the one that the racial bias is the one that is strongest. The age bias was significant. It was quite large. It was not as big as the racial bias that we found for sure.
What do you think the next steps will be with this line of study? I mean, I'm sure companies are very interested in figuring out what you're doing and how it can improve what they're working on.
Yeah, lenders and underwriters, I think, are fascinated by this technology the way most firms in the economy are trying to, just to understand how it can be used in their everyday business. So one very basic thing is it could help customers fill out forms, without errors in the way they put the information in. Like you can do a lot of customer service stuff potentially with the appropriate guardrails in place. You could, if you're a mortgage underwriter, you could explore, hey, what if in addition to just using our in-house model based on credit score and other things, what if in addition to that we had another model that basically asked an LLM what it thought about this. All right, so you could do that in a bunch of different ways. You could ask it to literally suggest a loan spread. You could ask it to suggest alternative loans that this person might be interested in, like say kind of modifications on points and whatnot. The way firms are going to use this is it's unclear, right? I think if I'm a mortgage lender, the first thing I would do, which is something we've explored a little bit, is just to see what the performance is of these models. Do they do a good job of predicting default, for example? Right, there's a lot of existing machine learning models you can use on mortgage data sets to understand what factors lead to more bankruptcies or combinations of factors. The thing that language models are good at is they seem to be really good at understanding kind of very nuanced interactions of factors, right? So maybe if I'm a mortgage underwriter, I'm definitely going to see if these things perform as well or on par with the existing machine learning models. If they don't, is there stuff we can do to improve the way they work? You tell it additional information to help the way it does it, for example, or you fine tune their outputs. Maybe you can get a state-of-the-art performance level on default predictions. And if I can't get to the stage where I think these are producing high-level predictions, you can use them for other parts of your production process, right? So you can use them to talk to applicants to help them sort through their options, so on and so forth. There's a lot of things you can do. And these interactions with customers are a little bit simpler on a regulatory basis than the way regulators look at, say, your approval decisions and your interest rate decisions.
If you were sitting down with a group of people that are leaders in the mortgage industry, what would you offer them as far as advice goes? Because I know, like you mentioned, like I mentioned, everybody's interested in this. What would be your biggest piece of advice for people to take away at this point in time where technology stands?
The value of experimentation. So what we did in this paper is we had a simple question about whether or not these things would respond in a biased way. We know they respond in a biased way in unregulated settings. Our paper is about a highly regulated setting, right? Mortgages. It still was biased, but the framework in which we experimented with it, we could measure concretely the bias, and we could measure how effective certain things were at remediating that bias. So if I'm a lender thinking about it, whether or not you're doing something like asking it to basically be an alternative underwriting model, even if you're using it in a different way, you can use it in a way. First of all, you should experiment. These things are powerful. They're getting better. You can only see what its capabilities are by using them, seeing what they're good at, what they're not good at. In our paper, we just carefully measured its responses to see how good they were. And any firm that's experimenting with these can do that as well, right? You can basically keep track of its responses and see what they do well and what they don't do well. And there's going to be a lot of value in that. These models are very good at processing a lot of information quickly and surfacing action relevant information. And you can imagine that working for a lending company in a lot of ways.
Thank you for listening to this Advancements in Technology podcast. If you would like to share what you are seeing in your market, please reach out to us at info@themortgagenote.org. Once again, my name is Kimberley Haas. Have a great day.